Okay, so hello, welcome to Package Drone, the OSGi first software artifact repository. So that was kind of a claim we put up to, well, give you a short idea of what the whole thing does. So a few questions first, please. Who of you has heard of a Package Drone? Okay, so who expects some flying objects? Okay, that's good. Because there are actually people who think it's a project about flying objects. So this is me, short introduction. I'm working for a company called IBH Systems. We're doing Eclipse SCADA. That's a project which is using OSGi for build. And at some point, exactly last year at the EclipseCon, we came to talk with a few people and found out that, well, OSGi is fine. We use Maven Tycho for build, but still there is a lot of shell script involved in the build process, which creates P2 repositories or OBR repositories or Maven repositories, and it would be nice to have a tool for that, so that all these shell scripts are gone. So who of you has a few shell scripts involved in the OSGi build? Yeah. So a short overview of what Package Drone actually does. We will do mostly demo today, but to give you a short introduction, what to expect from the system. So we do have, on the left-hand side, we have different ways of getting artifacts, which can be jar files, whatever you like. Basically, it's a set of blobs, which you get inside Package Drone. Package Drone itself has a few ways to store these, manage, analyze, and transform these blobs. And on the right-hand side, you want to do something with the blobs you put in the system. So you can get a Maven repository out. You can get an Eclipse P2, OSGi R5. We have support for OBR now. And since, well, you start with such a modular system, at some point you find out, well, you could analyze RPMs and Debian files as well. So there's support for APT and YUM, which is quite interesting at some point. So since this is a developer conference mostly, it may be of interest about what makes it fly, so what's underneath the system. So Package Drone itself is a modular OSGi web architecture. So I've heard a few talks about how to do things like this, so we did it as well. We are using Pax Web as a backend for HTTP in OSGi. We have Jetty underneath and JSP, JSTL support. We do have Equinox as an OSGi runtime, plus a little bit of Felix because they're doing a great job, so why not use it? It's OSGi. And now the biggest change in the latest or in the upcoming release will be that we ditched the database as a backend. So in the first releases we had JDBC database in the backend using Eclipse Link and Gemini JPA. But as my colleague said, well, don't do it, I told you so. So we did remove it. At some point in the future it might come back in a different way, but right now we're storing everything in the file system, which gives a huge performance boost. And of course, it's a modular system, so the plan is to extend this system, to extend Package Drone using plugins, as you know it from other systems as well. So at some point, we want to be capable of, well, you write the plugin and just drop it to Package Drone. And that's where the slides ends and the demo starts. I hope you can see what I'm doing here. The resolution should be okay. So as I am a lazy person, I prepared most of these steps in advance to try it out if it even works. If it's a flow which tells you how the system does its things to get into it. The good thing is this is all checked into GitHub. So at a later point you can check out the whole project with the README files and can try it for yourself. So it's like an introduction which you can replay at home. So starting with Package Drone, or first of all, what I did here, I have Package Drone running in the Eclipse IDE, so I have two Eclipse IDEs. Package Drone is running in one as a simple OSGi application, which is bootstrapped using the OOMP setup. So we have an OOMP file, which you really literally in 5 minutes can get a package drone up and running from your local IDE and make changes. So this is the web UI. So the main UI of package drone is the web UI. That's the main interface. So of course you have to sign in, and the first question is you bootstrap the new system, so how do you sign in? What we did is we have some admin token thing where I say, okay, there is a token on the command line or in a file, so you don't have test12 as a default password. And this all is explained in this little dialog box over here. So if you start up your package drone instance, don't worry, you will never find some default password. It's written right here in the command line or in a specific file. So I just copy and paste that over here. I log in as admin. I don't want to store that. So first thing we have to do is create a user, because the admin user is not allowed to do anything with the artifacts, so therefore you need a management user. So what we do is we create a new user. That's pretty standard stuff. So we don't need to put a name. Yeah, voila, gravata. So I change the password. So I can log in. No. We have field validation as well. I edit the user, and now I assign the 2 roles that I need. So sign out, sign in, remember me. So that's it. I'm good to go. Package drone is set up. So what you can do now, in addition, you can configure a mail server or configure if the users are allowed to set up their account manually. So you got here a few setup dialogs, but I will skip these because I think we're more interested in processing artifacts right now. So let's start with some basics. Basic elements are the channels. So a channel is just, well, a location for storing artifacts. It can be compared like a Git repository or yeah, some bucket where you put in your stuff. So we do create a channel. Let's name it OSGi1. And you see on the right hand side you got some recipes, but we create a plain channel, and that's it. So plain channel, empty with a name. The next thing we will do is we will grab some artifacts, and yeah, by accident I have here some Eclipse artifacts, which are OSGi bundles just out of the Eclipse build process. I go here, I drop them, whoop, reload, and there I got some artifacts. Well, yeah, this is funny, but not very useful up to now. So what we have is we have artifacts, and there are different kinds of artifacts. We have stored artifacts and virtual artifacts. The difference is a stored artifact is something that you dropped in by some process, and a virtual artifact is like a derived artifact, a generated artifact based on the original stored artifact or on other virtual artifacts. So each artifact, we can have a look at this, has some metadata. Right now there's no metadata at all because the channel does not have any functionality. So I have some basic data, but not more. So I want to add functionality to this channel to, yeah, do something with what I just did. I can configure artifacts, and there I get, yeah, like a list of functionality I can inject. So the first thing I will do is to add the hasher aspect and the MIME aspect. These are 2 nice aspects. Go back to the channel and just go to details and metadata. And now what I can see, some process in the background has extracted metadata from these artifacts, which are available now for processing in the background, but still not very useful. So I go back to the channel, I do configure aspects, I use OSGi, extract the OSGi back to that, details, metadata, and there I got some more information. Now it's getting interesting. We're getting somewhere. I get the channel, I add even some more. So what I will do now is, using OSGi, I get the, which one do we pick? We do the metadata generator. And we add the P2 repository. So next thing is, I see here I got additional artifacts. So this is now what happened. I have stored artifacts, and based on these stored artifacts, I got virtual artifacts, which, if I look at the right-hand side, I cannot delete. So there's a dependency. If I delete the parent artifact, all the child artifacts are gone, and so are the virtual artifacts. Now what I see here, I also get a classifier, so the system detected that this is some bundle it can work with. We got P2 and P2 metadata and artifact repository information. So the next thing that we see above here is we have the P2 link to the repository. If I dig into where I can download the full P2 repository for this channel. So now I look into this and I immediately see, well, if you know P2, this may look familiar to you. So you can download this, for example, using Maven Tycho. So it's providing a repository. Go a little bit further, and we say, well, look, okay, P2 is okay, but I'm an OBR guy. So I add the OSGi R5 index. Which at the same time, so OSGi R5 and OBR are in the same plugin. That's a bit confusing maybe, but still you will find the links over here. So I got an OBR repository, and there I got the OBR information. So this is based on the same information. So we added the OSGi aspect, which extracts OSGi metadata, and then we have P2 and OBR, which render it into the OBR and P2 repository. But still, this is something that we did manually, but in addition, we do another nice thing manually. Then we go to some more automated stuff. So I got two importers where I can import content into that channel. So I will try to import something using Maven, or repository URL. We leave it for Maven Central. I do select Apache Mina. I like this one. Careful here. Yeah, we have to be, because Apache Mina is built using Apache Felix, and there are some funny things ahead with the naming. So I want to include the sources. I go validate. I hope I have wireless LAN. Yes, I have. So it's trying to import. So let's see if this works. It did. So it was checking. So there are two steps. It's first checking that it's possible. It's making the resolution for the different things that Maven needs. And the second step is actually processing the import, which takes again. So import complete. I got two new artifacts. I go directly to the channel and see, okay, I got Apache Mina, and at the same time, I got an OSGi bundle. I got a P2 metadata. I got everything I had from the step before. Now, here comes another thing. I imported the sources, but as you might know that if you are working with Maven and with OSGi and the PDE tools, Eclipse and the PDE tools, the Maven source packages don't help you very much. Because PDE tools has their own format for source bundles, but yeah, you can add the Eclipse source bundle aspect. Go back to the channel, and you see, well, it created an OSGi bundle, which is a conversion of the original source bundles to the Eclipse source bundle, and you can use it directly in Eclipse PDE. So this helped us a lot for development at some point, but still this was all done manually. So it's a tool which can be used manually, yes, but on the other side you probably want to have some sort of automated build pushing your stuff directly into this. So we have a look at the next project, the next demo project. We have a plain Maven project. So this is nothing fancy. We got a class doing nothing. We got a Maven POM file, which is larger than the actual class. We are compiling using Maven. So this does nothing very fancy. It's just a plain Maven project. So the first thing we do, and we look in the README here, this is what you can read from the GitHub repository later. So we do deploy to package drone. So I do add the deployment descriptor here. Of course, I'm referencing here some channels, so I reference first the Maven adapter of package drone, and I directed to channel Maven 1, which we did not create. So let's go and create the channel, Maven 1, again it's empty, go to the right place, and then run plain Maven. So kind of have a look at this. This is just running plain Maven deploy. Let's go. It failed. Now why did it fail? It could not transfer the artifacts, blah blah blah, access denied. So you don't want anybody to just deploy stuff to your repository. So what we need to do here is we have deploy keys. So each channel has its deploy keys, which can be used. We don't have anything configured right now, so we create a deploy group. We add group 1. We add a key, which is called key 1. So it automatically generates what you have to insert into your Maven settings file. But still, we need to go back to the channel, Maven 1. Now we can assign this one. So we copy out the deploy key and head over to our Eclipse IDE. Now I will go to the user settings. So this is my user settings file for Maven. I paste the correct deploy key, and then we just run again. Build success, that sounds good. So I look at the content, and exactly here is what I have from the Maven deploy. So the thing is, as you see, there is no classifier, so the system didn't detect anything, but we didn't tell it what to look out for. So we configure the artifacts, we configure OSGi, we configure P2 metadata, we want a P2 repository. Yeah. I need some additional dependencies. Okay, go ahead. And that's basically it. So I do a refresh. So nothing happened. Okay, why did nothing happen? That's very easy because the jar file that we're producing actually is a plain jar file. So there's no OSGi functionality in it. So we just go back and add the next thing that we have. We add a little bit of code to build using Maven Felix. To get the right point. So now also Apache Felix. Yeah. Get it out here. And here. So what we do is we build using Apache Felix, the Maven bundle plugin, and we also built the source plugin. So there's one thing missing, because with Apache Felix you have to configure it actually as packaging bundle, because it's not a jar file anymore. That's a specific thing of Felix. Add it here. So we run again. Build success. Refresh, and there we see now we have two versions of this. We are doing snapshot builds, so we do have two versions of this thing, of the artifact, and one is an OSGi bundle now because the Maven bundle plugin did its job. We can see automatically generated P2 metadata, and if we have a look here, we have some P2 repository from Felix, building Maven Felix, into package drone and get a P2 repository. Of course, I can configure it here, let it create OSGi R5 and get an OBR repository. Same thing. Of course, the next thing is now you do deploy it using the Maven deploy adapter. So why not get it out using Maven? So we also have some Maven functionality in here. If you go here, the list grows longer of possible Maven stuff. Repository stuff, and we got a Maven repository at the same time, based on the same artifacts in that channel. So This is using plain Maven. Now, I have to refresh here. So now the next thing is, that was basically our use case that we have, because we were building it as a tool for ourselves. We do have Maven Tycho as a build tool. So what we have here right now is a Maven Tycho build file. This looks a little bit longer. You get target platform, you get dependencies to Maven Tycho. And what I did is I added several submodules to the build to have a bundle, a feature, and a repository. Down here I have a profile prepared for one of the next steps that's ahead of us. So again, I prepared the distribution management to deploy to Tycho 1. So we have to create that one. So that's another channel. Tycho 1. Get the deploy keys. So we already have configured the Maven settings file, so it shouldn't be a problem deploying to this right now. So let's go ahead, Maven Tycho. So the Maven Tycho build will take a little bit longer because, as you can see, it's downloading from the official repositories. Still, it was pretty fast. Now we have a look to the content. Okay, here we got some content. So what Maven Tycho does, it already prepares metadata for the P2 repository generation. The screen is a little bit small here, but I hope you can see it. We do have the POM files, and beneath the POM files we have the P2 artifacts. So these are artifacts files generated by Maven Tycho. We cannot, okay. So what we do now is we configure the channel. We configure the artifacts. And again, what we want to have is, we want to have a P2 repository. Okay, we need these two. So let's have a look. And there we have the repository. So in this step, what we did not do is add the OSGi aspect. So Package Drone recognizes these P2 fragment files, which are generated by Maven Tycho, and it's just assembling these to one big P2 repository. So all the metadata generation and the artifact generation for P2 is done by Tycho, and Package Drone just reuses this. So of course, if I go ahead now and add the OBR thing, it says, well, look, you need OSGi, because there is no OSGi extraction done right now. So I do add this, and at the same time, I get an OBR repository based on a Maven Tycho build. So now one thing that we can do is we want, maybe because of some reason we do want to have the same origin of metadata when using Maven Tycho and when using other things. So let's say I don't trust Maven Tycho's metadata. You can do, but maybe you don't want to. So what you can do is you can use OSGi, and there's the Tycho cleaner. Now the Tycho cleaner is one aspect which hooks into the process of artifact uploading, and which prevents these the P2 fragment files from being uploaded using the Maven repository adapter. Right now we already have the upload, so damage is already done, but we can clear the channel. It's empty. We just go back, run the same build again. Hope that it's pretty fast again. Build success. And there we see we don't have any sub-artifacts there, so the P2 fragments are not being uploaded. But on the other side, what we will figure out right now, we get an empty P2 repository. So OBR is still possible because we do we extract OSGi metadata. We do render the OBR repository, but for P2 we are missing the fragment files. We just deleted them. But of course, there is the metadata generator for P2. So going back, it's automatically refreshed and rebuilt. So the next thing we look in here, we have it. And this time, the P2 repository is built using the metadata, which is generated by package drone. So, did I forget something? Right. What we just did now is that we deployed to this channel using the standard Maven deploy mechanism based on every bundle. So every bundle is compiled, dependencies resolved, and then uploaded. So what might happen if you have lots of bundles and some break, you upload 50% of your bundles from your build, and the rest is missing. So what we can do, we can clear the channel again, and this is where the profile now comes into play. So I don't go into details because this is standard Maven profile stuff. So you can configure Maven deploy to skip some modules of your build, but not others. And I prepared this in a way that only the P2 metadata or the P2 repository, which is generated by Maven Tycho, is being uploaded. So I have to change my call here. Profile, run again. Again, it's built, it's uploaded, and there we get the repository. Now, again, it looks pretty empty, although we just had a working configuration, but still all the repository artifacts are inside the zip bundle. But again, we have a solution for that. We got the unzip generator, which just unzips everything. Now you can look here. You got the whole thing just on another level. So what you can do with this, you can actually ensure that at the end of your build, where your repository is built, the full repository is uploaded, not only 50%. Now, there's one nifty thing again. If you look in the documentation here, I will copy out the URL here. So it may be that you'd say, well, package drone, that's fine. It can generate metadata, but is it doing the right thing? Is it doing so? What you can do is there's the unzip adapter, which is just a URL adapter, which has a specific syntax, which we can see here on this line. So you can go deeply into a zip artifact and can access content from inside the zip file, from the outside. So for example, okay, we get here, and it's loading the content jar, which is coming from inside the zip file. As we can see here, the syntax, it's documented in the two links I wrote down below. There is a syntax here which says, okay, I want to have the latest snapshot, that's what the URL says, from the channel Tycho 1. I specify, again, some deeper path into this, and then using the group ID and the artifact ID, it's looking for the actual artifact, and it's deep linking into this artifact. In the end, what you can do is you can just use this URL and place it into your target platform. So it's accessing the whole zip file from externally, and package drone is only hosting the zip file, not more. And of course, what the unzip adapter also does is, since it's doing a lookup and a query, you can deploy in a continuous build to your channel. And then you can actually let it fetch the latest snapshot, the latest release, the latest 1.x version. So this is all supported based on the metadata from Maven, from the Maven upload process. So, as I said, we also have support for Maven, for Debian using Maven. So what I have here is a simple Java project which is building a Debian file using JDEB. JDEB is a tool for Maven which can build Debian files using plain Java. So again, up here I prepared, we have a channel deb1 which we need. So we create a channel deb1. And this time we're selecting one of the recipes because we want to have an apt channel for Debian packages. Now I do need to enter some information for the apt repository. I can enter here lots of data which is specific to the apt and the Debian system. I can select a GPG signing mechanism, which I have not configured here because I don't have any keys created. We just go with the defaults and have an empty channel. So again, we build. Now what will happen? Access denied. Because I did not add any deploy keys. Run again. There we are. Back to the channel. Again, it recognized, wow, a Debian file. I can have a look at the apt repository. So, yeah, same story here. So, back to the slides. So, this is the state as it is right now. It is an open source project, package drone. It has been accepted as an Eclipse project. That's why I'm here. We will have a release at the end of January, which is the first release hosted from Eclipse Foundation servers. So we are currently right now in the process of getting our CQs accepted. But still, for the future, what we do want to have is a bunch of features. This is a side project for me, so this is not my main job, sadly, but we hope to find some time to get this done. Of course, we want to have more plugins. We want to have a plugin concept which actually can use plugins from the web UI to install it, enhance the system. We do have a small REST API. We want to extend this as well. We want to have more repository adapters, of course. So if you think about software repositories, a few come into your mind, I guess. All these could be added in the system, I think. Of course, we want to have performance improvements. More artifacts are better, so improve the performance to gain there as well. On the right-hand side, first Eclipse release. This is also on our roadmap. It looks good that we can do it at the end of January, I think. We want to host an instance at Eclipse. So actually at the conference here, I came to talk with somebody from Concierge, and maybe we can try it out to get a system up and running there as a user zero, just for testing if it's working inside the Eclipse Foundation as a tool. And there we will learn a lot of things which are missing, I guess. So, but we know what to do then. And of course, it's an open source project, so if you have any ideas and time to code, feel free. One word of advice, we have version 0.10, which is the latest stable release. It will be superseded by 0.11 in the next 1 or 2 weeks. There is a release candidate out there, which actually is the final release, as it will be. If you start something new, use this version. Because the underlying format has changed and there's a migration process, so you don't want to have this. If you start new, use 0.11. If you just want to try it out the most easiest way, go to OpenShift. There's a quick start. So if you know OpenShift, it's from Red Hat, so you can host your server, whatever, on OpenShift. There is a recipe, so you just click a button on a website and sets up a virtual server on their infrastructure, and it's running it's running package drone in 5 minutes. So that's the most easiest way right now. There is more information. As I said, you can check out the full repository, the talk and the presentation and the demo from GitHub. These links should help you, and there we are at the point. I hope I was not too fast. So any questions, if you have? Yes, please.
Could you show us the layouts on the files on the file system?
The layouts on the file system?
Yeah, where you store the artifact that you will be.
Okay, I can do this. I have to say, okay, the question was if we can show the layout of what it is in the file system. So I will do that. But I wouldn't recommend using this as something that is a stable API. So we can have a look at this, but it might change in the future. So actually I did run it from my local IDE. So I get a bunch of JSON files, core properties. I got the user, for example, stored right here. I got the channels. The channel has a blob. The blobs are stored in some way. I got an index file where the repository index is stored. Again, this is nothing fancy. I get a cache file where some cache information is done, so there's some internal processing, and you see, for example, some things are prepared, cached, so they can be served faster to the end user. We got some state, so that's basically it. Yes?
Is it possible to mirror P2 repositories in the package drone?
Possible to?
Mirror.
Okay, is it possible to mirror P2 repositories to package drone? Not using the P2 mirror task. What we have seen is that you can upload a P2 repository zip file, which is expanded. So what we are doing is we are taking Orbit, Eclipse Orbit, uploading this as a zip file, and then using Orbit from package drone. Any more? No? Okay. So thank you very much for your time.